Um, all right. This session we are going to do the next of the buffer flow. So we have learned buffer flow, and the next one attached to buffer flow would be the format string exploits. So, we are going to now learn about format strings and then what would be the vulnerability of small format strings, and then the exploitation. Okay. Okay, so those are the areas which we're going to cover. So initially we had to understand what is this concept of format strings, which is kind of a very interesting type of vulnerability which is out there for some time, right? So basically a format string is a situation where you are supposed to print content to the screen or the standard output. So you can use concepts like logic or functions like printf. All right, so you know that you can say my age and you can give a formatting. So this is where you do the formatting. Okay, and then you can pass the integer value. So this is the normal structure of a print operation. So here in the printf you will find two different elements. First one is the format string. So this is actually formatting the string. You have a real string and then you have a placeholder here, the integer. So it can be any other thing, right? So other than integers. So you can use different types of data types. You can use a U stands for an unsigned integer or unsigned decimal, right? Or you can use a X, which is unsigned integer in the format of hexadecimal. So those are the basic cases where you pass as values. So these are passed by value. Okay, so basically it's a value. Depending on what you have here, your args or the arguments would differ, right? And also you can use pass by referencing. So you can use -s for strings. So it's like a character pointer. So probably if you can remember, so it's like unsigned, okay, and then you will probably, so it's basically a constant and then you get a character array. So even though you say it's a string, so this is how it's get formatted. All right, and then there's a nice one. So this has to be completed, but I just gave you a very basic idea, right? And then there's this cool one, which is a placeholder again, which is n. Let me check whether I can get the man page. Okay. Oh, right. That's good. So you can see a printf is able to formats and prints its arguments. So for a long time you have realized this is like to set up arguments and put it to the standard output, but see the definition also says a format. You format your strings. A format is a character string that you understand. Type of object, 10 characters, blah blah blah. All right. So then you have the arguments, and a leading plus or minus sign is allowed, so that we can learn later. And then you can use the special characters as well. And this is the one that I was talking about, the num. Right, so we'll come to that a little later on. And this is a long list. Yeah. Okay, so then is that, so this manual page is a bit different. Let me check. 3. Okay, this probably is more detailed. So if you go here, we will find a lot more details. Okay, so it won't take a long time. That you can go and read it later on. Yeah. So this is the one that I was talking about. The number of characters written so far is stored into integer indicated by the int star pointer. No arguments converted. So this is a classic case, right? It's a classic case. Okay, so that's quite an interesting command, right? So, okay, so go through this. It's quite interesting. All right. One minute is recording. Yeah. It's okay. All right. So hope that part is clear to you guys, right? So now, what's the problem? Like, what is the vulnerability? Okay. Now, the reality is like you will be able to format these strings, and then you are supposed to get the arguments through a hard-coded mechanism, or else you can get it from the user. And all the trouble comes when you're getting all these arguments from the user, right? So there can be a situation, so we'll try to understand this, where you will get a printf, all right? Where you get a printf, and you're not supposed to set up the format string, right? You're not supposed to set up the format string, and you will just give a buffer or a character array or something as the argument. So that's all that you provide. And then, so from args, we get the possibility of pushing all this information. So once we get that opportunity, we can do all the crazy stuff. Okay, we can do all the crazy stuff. All right, so that's a lot that we can do. So we'll try to work on that, right? Yeah. So yeah, before that, we try to do a small experiment and come back to this. So this is actually the problem. Like, so when we can provide these arguments, right? The way that we want, right? Functions like printf, and there are some other functions, right? Provide a whole lot of interesting exploitation options, right? A whole lot of interesting exploitation options. Yeah, so this is what we are trying to understand, right? So yeah, so we try to look at it. Yeah, so first of all, we'll try to do a small experiment to get things going, right? Okay. Alright. What I'll do, I will initially write a small program just to provide you a bit of experience on how this thing works. So I'll write a C code. Okay. So I will define the integer and also a float 5.5 and a character array or a string for that matter. Let us see set. Alright, now we'll do printf. Hope you guys can see this. Alright, that's good. And then I'm going to format the string. So A should be, formatting should be for integer, done. And then B will define a float, and then C will define a string, no? Yeah. Yeah. So we'll define a string, and then we'll have a new line. Okay. Oops, sorry. So then we have to provide A, B, and C. Close the bracket. That will do. So I'm going to compile this the easy way. Okay, some warnings are there. Do I care? No. Okay, so there is an error also. Okay, so it should be printf. That would be. Now all warnings. Okay, now there's error. Okay, so it should be character. I think that's fine. Alright, so now if you run the example code, you can see A is defined as -5, B is defined as 5.5, a float, and then the character. Alright, so this is basically a kind of a simple program explaining the format strings. Okay, so what else we can do? You can probably do something like this. Let me check whether it works. Okay. Yeah, so basically what I've done there, I have added some padding. So I can format this as I want. So that's the whole idea here. So you'll be able to format this. So it's a lot of fun to do this, right? Yeah, so that can be done. Okay, so now we have seen an example of where we'll be able to format our variables. Okay, now what to do? And now we go back and try to see or try to understand the next step. Okay, now we have not yet explored the idea of format string vulnerability. So let's see whether we can do a bit of experimentation with this. Okay, then we'll try to see. Now, this format string vulnerabilities are highly linked up with buffer flows. Okay, so now if you try to compare these two, right, buffer flows and format strings, so we are yet to see like all the possibilities that we can do with format strings. We'll come to that. Don't worry, just hang around. The fun is yet to start, right? But we'll try to understand some of the differences. Now, buffer flows was there from mid 1980s, right? Uh, so they were so popular at that time. But format strings was found in late 1990s, so around 1999, around June of 1999. So that's probably the first case where format string vulnerabilities were found. And the danger was realized, like this was there for some time, and then the danger was realized in 1990s, where this was 1 year after in year 2000. They were realized there was so much of worries, right? And if you look at buffer flows, of course, buffer flows are so famous, right? So everybody knows about buffer flows. So there are thousands of different types of buffer flows, right? Every day people are coming up with a new buffer flow. But here, like few dozens, we say less than probably 100, right? So you don't find a lot of format string exploits. And normally, buffer flows regard to be security threats. So those are regard to be security threats, whereas format strings are programming errors or programming bugs, right? Programming bugs. So if the programmers are more intelligent, obviously, like it's not that easy to do format strings. And also, these are like evolved techniques, like advanced techniques. This is also advanced, but these are like regard to the basics, right? Visibility of buffer flows are hard, but format strings are easy to find in that sense because it's not a very hard thing to understand, right? But yeah, but there are lesser exploits, right? Lesser exploits. And also, when it comes to different types of formatting vulnerabilities, there are some famous cases. There was this FTP server from one of the universities, so that was hacked uh, 6 years back, right? And then Linux RPC, they had a problem in the library std, right? And also there was a telnet issue. So there was a telnet client, I can't remember, IRIX or something. So they had another issue. And then one of the cups, Linux cups, that is for printing, they had the issue. So there were several issues found out on format strings. And later on, I'll share one of these DEF CON videos or DEF CON sessions. There was a kind of a good explanation about a format string vulnerability, right? So there are plenty for to understand, right? So next, we'll try to understand what are those functions which we basically see, which you can try out this format string vulnerability. So there's a list of functions. So rather, I think I will try to get a list here. So these are some of those famous functions: fprintf, printf, of course, and then sprintf and ef printfs. So that's plenty of functions, right? So these functions are having all of these things are having format string options. So these are vulnerable for format string vulnerabilities. And there are some other relatives also, relative functions, related functions. Uh, so these are some of these functions. Set proc title, syslog, and few other functions are available as well, right? So these functions are used to for different tasks, like say most of the time formatting and putting content for a file. Uh, so basically, you deal with data, right? You deal with data, right? So you're handling data here, and allow the specify formatting and processing the strings. So that's what they do. And when you do the formatting, the format strings controls the behavior of the function. So basically, format string that we have seen, so basically handles all the functionality. And also, now we are coming to the important parts, right? So format strings provides a capability to handle all the parameters, and also whatever you are getting to the arguments, the format string has the ability to push them to the stack. Okay, right? This is where it gets interesting. So format strings, so all this data will be remaining somewhere here in the stack, and then rest of the data, say if you can remember the previously I used A and a B and a C, so those things will go up in the stack. So those values will be in the stack, right? So when I place a D and when I place an F and when I place the S, so all these things get added to the stack. So that is quite cool. So later on we'll get those basic ideas and try to do our uh, exploitation. All right. Okay. So moving on. So so to do that, if you do the stack, so this is the top of the stack. This is the bottom. Again, I'm drawing the same thing, right? Bottom, and then this is your format string, and then all the variables, right? So A and the B and the C. So this is the top and this is the bottom, right? So now you can be able to access rest of the values. And we'll see it later, you'll be able to access probably throughout the stack. So that's the cool thing. All right, so now you've been listening for some time, so we'll try to do a small experimentation. Otherwise you get bored up. So you'll be waiting to understand how this exploitation works. Yeah, so without due, we'll try to understand that bit. For that, I might need another small function. So let me go to my curly box and write the next function. So this one I will name as evil.c. Okay. So I have to make this evil. All right. So int. So we'll define argc and we'll define argv. It's normal. That's all we need. And then I'll define a character array, right? 1 to 8. Okay. And then I'm using one of the functions. So basically what I'm going to do is I'm going to take this argv1, so the first argument, argv1, all right, and I'm going to put it to b character. because I want to be there also. And then I'm going to print, which is bad, no? Just wait and see, printf. So rather than putting something like this, so this will be a string. So ideally, if I did this, the story ends here. So the story ends here. If I do this, right? But I'm not going to do that. So programmers do mistake. I do a mistake now. Oh, I did a mistake now. Oops. So of course, try to understand bad programming. Okay, bad programming. Who cares? Right. So this is a very famous program. If you browse the internet, you'll find plenty of very similar type of codes. This evil code, end of evil. How good it is if it's end of evil. Save it. Right now, there are a few things to remember. Now, this to work, there are a few conditions. First is I'm using a 32-bit machine, right? So it's a 32-bit machine. 64-bit also this can be worked out, but there are some issues, concerns. So I'll try to make it easy as possible. So I'm using a 32-bit machine, and I'm using a very new Kali machine. The Kali image which I downloaded. All right, and yeah, so Debian. That's the first thing. Yeah, that's basically it. So you also, if you're doing this one, please get a 32-bit machine to get things working smoothly. Yeah. So then I need to compile this, guys. Okay, I will create a small note on how I'm doing this thing, and I will give it to you. So sometimes when you're doing this, you need this particular tool. It's called exec-stack. Right? So it's a tool to set clear and query executable stack flag and ELF binaries and shared libraries. So what we're dealing with is ELF binaries, elves, Linux elves, and sometimes we use shared libraries. We'll discuss more on this later. And this can set clear queries, executable stack flags. So this can be quite a useful tool. And here the user can override this assembly time through exec stack or no exec stack assembly options. So this can be an important option. So we're using this exec stack, right? So we come to that later on, but remember we are using this. If you don't have in this your Kali box, please do a quick apt-get installation. This can be useful, right? So there are two different ways you can run this command. I'll show it to you. So this is basically the compilation I'm talking about. So initially, please remember this command. When I'm using this GCC, I'm going to use, I'll come to these explanations later, no pi, right? And then z, and which I use exec stack, all right? And then of course my compilation. So I would say evil and then evil.c, right? So this is the first way of doing that, right? So I'm going to compile. I'll get few warnings which I'm not going to really worry about. So there is the string copy warning, and then of course usage of b directly without using a format string. It is not good, but who cares? All right, so that is done. So I'm going to take my compiler command. All right, and I'm going to make a small note. So the first thing is compilation of C code. All right, so that's the first one. Then I will say this. done. That's good. All right, so that is there. So compile is I will have my evil executable, but there's another command which I should run. So this will also will help in controlling some of the execution of my code. So I'm using the sysctl command. Again, if you don't know about this, you can run the manual page, configure kernel parameters and runtime. So if you look at, I'm going to use -w. So I'm going to set a parameter which is called randomize the VA space. So we are going to talk about these things later. So I'm going to run this first, right? So I have to run it as a root. Sysctl -w. So I'm going to write to the kernel space kernel, and then you have to say randomize the VA space, right? And this should be set to 0. So they will ask for the password. Yeah, so now you get this. So this is an important command to type. Okay, I'm going to copy that as well. And so this is the next one you have to do when you do the compilation. All right, that's good. Okay, so now basically we have a program to run, right? So now it's probably the time we are going to have a bit of a fun. All right, so now what we are going to do. Okay, so let's start hacking. So okay, I have my evil code, so I'm going to run evil. Okay, segmentation. So, that's bad because I have not given any inputs. So now so start with slit. Okay, so when I get the input slit, it works. It works perfect. All right, now what I'm going to do. Now, if you can remember, it doesn't do any formatting. I can put anything into my function, which is cool. So now what I'm going to do, I can, of course, provide any value, any large string also. It could, okay, it would work. Okay, yeah, so it works. Not a problem. So now I'm going to do something interesting. So with my arguments, right, say a, I'm going to provide ampersand d. Now you see what's going to happen. Nothing happens. Then ampersand u. Nothing happens. And then I'm going to use ampersand x. So if you remember what we discussed, ampersand x stands for what? It's a hexa, right? And okay, so nothing happens. But if you do this, let me check with this first. All right, what's happening now? Oops, what's happened? Is there a mistake? So what's still happening now? What's still happening? I can't even think of what is happening. So normally we give the format string like say printf. I'm going to give the format string my age, something like that, age, and then percentage d, and you do that, and then you provide the argument, real argument. That's what you're doing now. So now what happens when you say my age ampersand d? So basically it's a placeholder and the formatter. This gets the value say 9. It gets the 9 value and get forwarded it to the standard output. So when you do that, this value gets written in the stack. Okay, so this value should get in the stack and to the standard output, and basically this string will be in the stack, right? So now what's really happening here, because of this logic of accessing the stack, right? When you put this value directly to the printf, now knowingly or unknowingly, right? So I'm going to put it after this value. So check this one. Yeah, that also works. So what happens now, it checks this a, right? And then it prints the next, right? As a next argument, it prints the, so there's no argument provided. So of course it gets that memory location value and then it prints it. So try to observe what's happening there. Quite interesting, right? That's quite interesting. So basically there is a mismatch. So the function printf fetches the argument from the stack. The format string needs 3 arguments. So it doesn't have 3 arguments. It will fetch the 3 data from the stack. So does it work that way? So let's see. It needs 3 arguments. Another one. Oops, it takes another value. So see, all these things probably getting from the stack, isn't it? Yeah. So that's another argument. So we are getting a lot of arguments. Okay. So what if we do a u? So that's unsigned integer. Here a u, so that was a signed one earlier. Yeah, that's now it's unsigned one, which is cool. Okay. And also we'll try to do a s. Oh, no, it doesn't work. It's okay. The x, okay, we get the hex value. All right, so now what if we do this? We'll say 0, 8. Okay, no difference. So if it is 8, should be 8 digit. That's a 60. Yeah. So it's padding things. That's all right. We don't care about padding now. But padding can be important in a later stage. Okay, so we'll try to get things more clearer. So we'll try to now something like this. X dot x dot x dot x. Oops, it works perfectly. All right. So now what I'm getting is 3 arguments after this input of mine, which is a, that's which I provided. Rest of it will come automatically from the stack. So I put some dot notation where I'll be getting the values in hexa. I need some decimal, you put d. So now okay, so try to get a more clearer view on things. So what should be happening here will be this, get a new page. So now get it clearer. Okay, so what you get is your format string is here, stack goes to this direction, this is the top. Okay, so now this is A, this is B, and this is C. So I have put some values somewhere here, A, right? I can't say exactly here, it can be anywhere, right? Okay, it can be even here, A, right? But I ask for X, so actually it gives some address somewhere here. Another X, another address here. Another X, another address here. So that's what I got, right? Hope it's clear to you guys. Okay. So truly what's happening, all right, truly what's happening, uh, when I wanted to print this, okay, this is what I did, no? Yeah, let me print this. So this is what I did, okay, X and an X and an X, and I use the fourth one, yeah, that's also I can put in. So what's really happening here, I will be getting something like this, right? Printouts contents of the address someplace, right? And I'm going to get these values, no? When I say access, I'm going to get these values with the use input. Okay, that's a bit cool. Okay, now you go here, the curly box. Now. Okay, now I print the fourth one, right? Another one, X. And what I'm getting here is something, something that we have seen, no? Something that we have seen. Not really sure what is it. Let me get a calculator. Okay. Okay. And I'm getting the scientific calculator. Oops, that's cool. So now I have this value. I'm not really sure what is it. 41414141. So that's what I'm getting at the fourth parameter. So let me check from. Okay, no, I should be. Yeah. So actually, no. No, I can't do it from the cat. Sorry. So actually, no, I'll do it this way. A. So I have to do the ASCII, right? Sorry, I should do the ASCII. Yeah, that's what I need. So ASCII X. Do you have something like that? Ah, yes, we have. That's good. Okay, so I need text. So ASCII. Hex to ASCII. I don't know. I'll do ASCII to test. That's okay. Yeah. So now what I inputted was A and convert. All right. See, 41. I do B. I get 42. C. Yeah, got it. Now I hope that you got the base idea. Right? So what you find here is basically these A's, right? So now what's happening? This is my input, right? This is my input. So it get loaded up the stack, not the place where the stack starts. The first value is this one, not the second one, not the third one. Ah, yes, the fourth one. So the fourth one contains this 41414141, which is my character. So what do I mean by that? So it's a very strong finding. So whatever I inputted, now it's get represented in the stack and I can retrieve it. So this is informational retrieval, right? So of course this is also valuable, right? This is also I'm getting things from the stack. So it does mean something really valuable where I'll be able to capture details from the stack. So which is good. In many ways it's good. So I'll be able to do few other things with this, right? So if we can retrieve that value, all right, so I can retrieve it. So that's really fun. Okay, so now what else we can do, right? Now what else we can do? So now we have to think what to do next. All right. Okay, so now I told you there is another small option which is N. So all these are reading X, S, U, D, X, all these things are reading options. I read only options. You are going to read from the stack. But there's this crazy one which is called N. N stand for writing. So what you're going to write, whatever the bytes that you have inputted up to this point, you can write to the stack. So let's try to do this. Now, if I can do this one, it means a lot because I can write things to the stack. The problem is it gives a segmentation fault. So don't get it wrong. This is normal because I'm trying to access a memory component which is not given permission to me. So I'll not be able to do that. But probably somewhere here, maybe, yeah, that's, okay, sorry. So there are also no, maybe here. No, so though I don't have that permission to do that. All right, that's okay. That's okay. So we'll try to see what we can do with this. So at the moment, there's nothing I can do, but we'll see. So, but before I go to the other section, I just wanted to see my file, my object file. So if I do this file command, it will show few interesting things. It's a ELF 32-bit LSB, and sometimes check your files. If it's a shared executable, you end up with trouble, right? And also it should be non-stripped. If it is stripped, that's also asking for trouble. We'll discuss about how to handle these stripped functions and shared executables later in a second session, but initially I'll be going with very basic stuff. All right, so now we go to our table and we'll try to understand a bit more. Right, so so we have learned now basic format strings, how it works and how it can be exploited. Right, so a bit more about format strings. Now remember, percentage X is what we are using most of the time. So this is for hexa, right? This is for hexa. And then we'll be using, sometimes we'll be using things like 8x. So what do you mean by that? So because sometimes you have to fill information to the stack, right, for different purposes. So what do you mean by that is, of course, a hexa, but before your hex value, pad with 8 characters, 8 chars, right? So pad it with 8 chars. So that's what you mean by that. And of course, you can do 1000x, right? 1000x, meaning pad with 1000 characters. Hope it's clear. Right. So now, right. So these are the situations. Try to understand because you will be using a buffer, and that you will be sending with the string most of the time. It's the string copy to your printf. So there is quite a possibility of doing a buffer flow also. But remember, we are not targeting for buffer flows. And of course, next session we're going to do this exploit exercises. They have a nice set of CTF boxes. So there also you have a nice set of things to do. So there are also you can try out with buffer flows, but it's out of bound for us. All right. Okay. Now, and also remember, we use the format of printf with arguments, right? With no arguments, sorry, no arguments. So this is the model that we use. Oops, and an X. So this is what we did actually from our setting up arguments. So, but the printf didn't have any arguments. So there was no arguments. So no arguments. So we set up what we want. There were no arguments. And also it should give error message. So what happened was C language and the printf retrieved the 4 values from the stack. It retrieved the 4 values from the stack. So that we have seen very carefully. Right? So I have drawn this several times. So you are here and you're accessing those values from the stack. And also we try writing also to a place with percentage n, but it didn't really work out because we haven't had the permission to do that. Right? So basically we have the read capabilities. Up to this point we have seen the read capabilities, which is basically a information disclosure, right? So it's an information disclosure issue. All right, so that's okay, that's cool, right? um, so now what we should try to do is to go beyond that, right? Go beyond that, and then try to do exploit. So where we can be happy that format string is a kind of a great utility for hackers, right? So we should be able to write to the uh, stack, write to the stack, which is writing to the RAM, right? So writing the RAM is great, you know. And also remember, by this method you can do a DOS attack also, right? Denial of service, but we are trying to do more of exploitation, right? Using probably things like remote code execution, right? And remember, for these things, next we are going for the exploitation. But before that, you have to understand there are defenses against format string vulnerabilities. But most of those the defenses sometimes does not work. So there are stack defenses when you are in the stack, especially hackers use, like you're jumping from one stack to the other stack frame, and then of course you have to return to the previous stack. So you have a return address. So this return address, by changing the return address, you can obviously take control of your memory. So to stop that, remove from the stack return address, change in the return address, right? To stop this, these days we have something called canary values, right? So this canary values is a good option. So study about these canary values, good option to stop overflows, especially buffer overflows. But still, this does not really work for format string vulnerabilities. So this is the first defense, but it doesn't really work out. So it's not really vulnerable in that sense. And then later on we'll discuss there's this uh, ASLR, which is a different topic all throughout. So this ASLR also is there, but it doesn't really make it impossible, but it makes things difficult to do. Yeah, so those are the few major defenses. And also, like, programmers can look for errors, right? And of course, very importantly, the GCC provides warnings, but who cares about warnings, right? Unless otherwise there's a real error, people do not care about the warnings, right? Okay, now what we're supposed to do, so we have to look at the steps to go through. So now we have a nice coding. So the coding, if you can remember, setting up a buffer and copying the args to the string copy to the buffer, and then put the buffer to the printf. So this is the code that we have, vulnerable coding. So we are going to use this coding. Now we are trying to build up a model of how to do the exploitation. So we have to control the write. So we have to get the end going, right? So we have to do a write, and then we have to find a location to write. Okay, that's the important thing. We have to find a location to write which we can write to. So we started writing, but it didn't work out. Now we have to find out a good location. So that's the first challenge, right? Challenge number one. Okay, challenge number one is to find a location, and then if you find location, you can probably write 4 bytes. So 4 bytes means you have address. So if we have a location to write the 4 bytes, right? So then we can get access to space, real estate in the memory. That's what we need now. So we have to have a real estate in the memory which we can point to. The buffer flow, of course, remember, right? Now, why in the world you need a memory real estate? To do what? To do what? To insert the shell code. So if we can insert the shell code to this location, done, no? Done deal. Then of course, program execution goes to the shell in the memory, execute the shell, and we get U done, right? So this should be this plan. Okay, this should be the plan. Okay, uh, so why don't you try this out? So only concern is when you're trying to find this location, right? So when you're going to get the RAM, right? So the options we have is get the return address. That's probably one option. Second one is using GOT, global offset table, which I'm going to discuss, and which I'm going to use global offset table. And there are other things like detours. Detours is like constructors, there's destructors. So when you use constructors and you do classes, destructors means you are going out from the program. It's like more like return address. So that's also can be used. So there are few options to select your location. Okay, we talk about this. GOT, we talk about GOT, don't worry. This is our way of doing this. Return address we tried out for buffer flow. Detours probably we'll try out in a different time. And then also C library hooks. So hooks also there. So these are the options that we can try out. Okay, so but we are going to use GOT. Good, right. Now, yeah, now we'll try to hacking. I'm not sure until we do this, so don't get me wrong. If something wrong happens, please, 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 don't worry. So we'll try to work it out. Okay. Fine. So now we'll go to the curly box. Right. Now we are good to go. So now what I'm going to do, I'm going to run the, yeah, I'm going to run the GDB. So I think it's good to play with the GDB. Yes. Yeah, fine. So let me open GDB and queue for quiet start, and I will get the email. Did I miss anything? Right? Okay, so it's good. So let me run this now. Run with basic stuff. Okay, that works fine. We'll do the basic stuff. That's also fine. Oops, okay. X, so X. X. So now, yeah, so you can see 41, 41, which is 4 A's. And then I will do another X for fun. Alright, you get 42, 42, which is the B's. Okay. Now what to do? Yeah, now this time, let me check the disassemble the main. Okay, now I see the basic stuff. There's a call, not really worried about that, that's another function, and the string copy is there. Okay, not interested. All right, this is the printer, which is the most interesting function, and apart from that there's a putshell. Now see, like what we're trying to do is like find that location where you can insert something, right? So that's our logic now. Okay, so now what I'm going to do is I'm going to put a breakpoint to the printf. Okay, let me put a break to main plus, what's the number, 68. Okay, so then I can run, right? Yeah, so when I'm running, I'm going to yeah, I will do this x x x. Okay, so I'm at there. So let me check the EIP. Okay, so I'm at the call, so that's all right. That's all right. So I can continue. Okay, next, I will check the EIP. Right, there's no register set, so everything is fine. Okay. All right. So let me go back to the prompt. Okay, now I was trying to look at the GDB. So I'll open reveal. Okay, and then what I'm going to do, I can run the code. So I have run as earlier as well. A, A, and of course to do my write operation. So that's what I'm planning to do. So let's see how the write operation works. So the fourth one, so I get 4, right? So that's the idea. So now, ideally now what I have to do is, rather than putting x's, I put an n. Alright, so that's basically where I'll be getting a segmentation fault. Previous also, if you can remember, when I'm running the program outside GDB, I got the same issue. Right now, I need to do some with some understanding of how to uh, find the location to write my value. So that's my problem now. So what I'm going to do, I'm going to make this a bit different format, so it'll be easier for us to continue. So rather than putting a lot of x's, I would say percentage for fourth argument. I'm going to use the fourth argument, and I'm going to use n. So it's the same thing, right? Same thing. So it will be a short format. Fine. So same thing happened. So I get the segmentation fault, and it writes to a particular address. So it's not really worried at the moment. So now what I'm going to do, I'm going to look at my EIP. So this is 30-bit machine. So I'm having the EIP. Yeah. So now when I look at it, so I see a move operation. Say, now try to understand there's an n, right? So now I have to find out what do you mean by this n. So ideally, my whatever the value, right, that I'm going to input, which is this one, need to be written to a location, but it doesn't work. So that's what happens. But let's try to see like what is the operation. So let me now check on the ECX and EAX. So to look, I can go with XX, or let's say print print the value. So I'm going to look it from hex values, ECX, that's on the left hand side, which is 5. What is 5? 0x 5. So if you want to look at from decimal, it should be a 5. Yeah, it's a 5. So clear. Yeah. So yeah, if you need the this is operation. And so ECX is 5. What is 5? If you can remember the run command, so what you have here is 5 inputs. See, A, and a dash. So that's 5, right? 5 inputs. So that's why it says 5. Okay. Now what I'm going to do, I'm going to look at EDX, sorry, ECX, EAX, sorry, EAX. So not the instruction, but the value there. So I'm going to print the value, print the hex value first. Ah, that's nice. So that's AAA, right? So that's AAA. So basically, you're copying that 5 to the place AAA, but I don't have access to this address. That's the problem. So this AA means address. So in the memory, there should be address called 41414141. But the thing is, I don't have access to. That's why the segmentation fault is there. So now what we have to do, guys? So we have to now we understood that from this statement, what's really happening. We give the address where we want to write something. To that location, it tries to write 5 bytes, which is the input value, right? So, but the problem is now 5 bytes been taken, right? But the problem is we are not possible to write it to the address because we don't have the right to it. So now what I'm going to do is just to make sure things go in the same way. Yeah, I'm going to put another 4. So altogether the input would be 9. No? 4 and 4 another dash. Okay, segmentation fault. Yeah, fine. So now I'm going to check the EAX. So you can see, sorry, ECX. No, it should be the ECX. You can see the 9. So hope it's clear to you guys. Hope it's clear. So if I put even more characters, that's what's going to happen. Okay. Then what I'm going to do, I'm going to have a bit of a fun here. Let me check with adding more elements. Then you. Okay, now I'm going to check the ECX. Okay, 13. So that's adding this 10 also together. Right, so calculator 13 is hex 13 is from decimal 19. So you have 19 altogether, 9 and plus 10. So hope it's clear, right? Hope it's clear now. Okay, now what I'm going to do, now I have done some playing with the content. So let me now do a small trick, right? Now what I'm planning to do, I told you previously, if I want to find the location, I can use this concept of GOT. So that's what I'm going to do now. GOT is a global offset table. Okay. Now to get to the global offset table, I will jump out from here, and then I have to look at the object file. So I'm going to do an object dump, a recursive dump, and we'll look at the object file. All right, so now when I look at the object file, I see some interesting stuff. All right, so what do I have here? I have the printf, and then this is the address of that. So printf is a function where the stack has to move to a different stack frame. So that stack frame's location is 0804C00C. And then you have string copy calling. If you can remember the disassembly of main, you jump to that one. So that reference location is put in the dynamic reallocation table or the uh, GOT, right? So this dynamically allocated. That's why it's there. And also then there's a putSha function, and that's also there. So I need this because what I'm going to do is I'm using this putSha function. I'm using this particular location to try out this memory location. So let me go to the GOT and run access. So my idea is to get the run access, and also here my intention is to use putSha, return address of putSha. Okay, so which is this one. Okay, so I have to get the address of that. Paste. So this is the all important place. This is my point of interest. Okay, I'm going to save this, which I'm going to give this to you later. Okay, now good. So now what I can do? Now I should be able to try writing something to this location. Okay, that's my purpose. So how can I going to do that? Okay, so let's see. Okay, let's see.